So thank you all for being here today to hear us talk about our favorite things about data this year. So let me tell you what to expect. This is not super in-depth, technical, learn how webinar. What we're trying to do here, it's the end of the year. We're trying to have some fun, and our real focus for the webinar today is the art of the possible. We get excited about what we do. We're very passionate about the work we're doing. There's a lot of things this year where we've had conversations internally about, wow, this thing here is really cool, or I really like this idea. Boy, I wish people knew more about this technology. So our idea was just to get a bunch of our big brains together and just share with you the things that we're most excited about and just enjoying about what's going on with data. And what we're really hoping the takeaway is that you're seeing what's possible. You're seeing the cool tech that's out there, the ideas that are out there, and hopefully they inspire you or give you some ideas about things that you can do. Maybe they'll some of these will hit on some problems you're having, or maybe even just some interest. So that's the goal of our presentation today. On that note of being somewhat laid back, we do want this to be interactive. So we have a Q&A chat bot, not chat bot, I'm sorry, just chat option that you should see on your screen as you're watching. If you don't see the chat bar open now for submitting questions, you should see something with some speech bubbles and a question mark on the top right of your screen. You send those questions. We're going to be reading them as we go. And we'll take some of those questions and make sure to bring those up with the presenters. So feel free to just type those in, and we'll go ahead and get started here. So here's who you got today. You have yours truly, me. I'm Chris Hoyt. We have Josh Barth, our senior data architect. John McCullough, he's our app development director, and Bill McClellan, our solutions architect. Little quick intro here. So I've been here at Onebridge just over 2 years now. I'm a tea connoisseur. I have 67 ties, but I'm not wearing one today. And I play Animal Crossing a bit too much for my age. I don't know if there's any other Animal Crossing fans out in the audience. Josh Barth, senior data architect, also been here about the same time as me. Certified in Alteryx, Tableau, Denodo, fantasy football fanatic, and frustrated golfer. Not sure what that means, but John McCullough, he's been here 8 years at Onebridge. He was a volunteer marching band instructor, placed 4th in Indiana State yo-yo competition, and lock-picking enthusiast. I just want to add that I almost added yo-yo as a fun fact to mine too, but John beat me to it, and I still can't get over the serendipity of two of us enjoying yo-yos. Bill McClellan, 4 years at Onebridge. He crushes it at karaoke. Sadly, that's not something I personally witnessed. I'm hoping to soon, but that's what I'm told. He's scary good at throwing an axe. I have seen that. And he really rocks his glass as well. So to get started, first up here, we have Josh. He's going to be talking to us next and about his favorite things. He wanted to get started, though, with this quote. So I'm going to hand it over to Josh and have him talk about this and as he gets started.
Thanks, Chris. Good afternoon, everybody. Thanks for letting us take the time to kind of hang out and kind of wind down this long and crazy year talking about some of our favorite things. I'm going to really be focused on 2 applications that really gets me excited and things I have experience with, and we'll kind of go through those, see what those tools are going on and why they really get me going. But to kind of kick us off here, I was looking at data quotes the other night, and this one really hit me because it's kind of something that all of us data nerds can really relate to, is that data can sometimes be like garbage. And when you want to just pull everything in like the business wants you to, you better know what you want to do with it before you collect it. And if you think you go back, 5, 6, 7 years, really the power of data was really in the people's hands that knew how to use the tools, or if they knew how to write SQL efficiently, or if they had dare I say, an access database lurking around somewhere. That's really where all the power laid and how you were able to interact with data. Where now, Chris, if you want to go ahead and go to the next slide, where really the power is transitioning to from an application standpoint, at least from a data, wrangling, transformation, discovery, is that we kind of queue in Alteryx. So Alteryx is this awesome tool that has really revolutionized how people of all skill levels can interact with data today. So you think, like I was saying, 5, 6, 7 years ago, you were kind of really boxed into doing a lot of manual SQL. I'll go back to the years of, DTS, and then when SSIS 2005 came out, we all thought that was great. But now we're at a point today where I can pull a data set from, any disparate source, pull it into Alteryx, and immediately start doing, transformation, joining of data, blending of data, mapping of data, just all these different things. It's funny. My wife and I were watching Forrest Gump for whatever reason it was. And when him and Bubba started talking about all the different ways you can interact with shrimp, I really started thinking, man, that's a good analogy for Alteryx. You think like, for data, you can blend it, you can join it, you can transform it, you could clean it. I could keep going on. I don't have enough fingers really to call out all the great things that Alteryx does for us today. And I've had, the pleasure of working with it for the past 3 to 5 years. And really, what we're kind of going to go into today is I'm actually going to show you guys I know Chris said we're not going to get into like an in-depth technical demo, but we're actually going to do a live problem solving session with Alteryx. So one of the other things that I love about this tool is that they really promote community and learning, and really understand that some of their users can range from, that basic person who doesn't know a lot about databasing and a lot about, ETL and data concepts. And then you have, of course, those power users that are building these crazy interfaces and all these crazy, spatial technologies. So really what I really love about this tool is they have a community site that has these, they kind of air quote them as challenges of the week. So every 1 to 2 weeks, either it'll be user submitted or community submitted. They'll have this challenge that involves data. They'll provide a data set and they'll say, hey, given data set, ABC, go solve problem X, or tell us how I get to problem XYZ. And of course, they provide you the solution, but really the fun and the discovery is getting to that. So that's what we're going to do now. So I'm going to go ahead and take over the presentation and share, and we're going to kind of run through this problem. I tried to keep it as festive as possible, being that we are at the holiday spirit, but I will say that the holiday will be representing this data. We may be a little bit, a couple weeks too late, but that's okay. For today's example, it'll work great. So Chris, if you don't mind, I'm going to go ahead and share, and we'll go ahead and get started here. So like I said before, with these Alteryx challenges of the week, really you kind of just go out to the community site, you pick one that looks interesting to you or one you haven't done yet, you download it, and then you kind of open it up in Alteryx Designer, and it's going to basically, they're kind of all prefaced the same way. You're going to get a nice box of what is really the problem statement here, what they're wanting you to interact with. And then of course, if there's multiple basically pieces they want you to output, it'll be here. So for this one, if we already go again into it, it's about Thanksgiving. So all the dishes that were served at Thanksgiving based on a survey they did, I think it says 2015, but basically they asked, I think it was like 1,000 to 2,000 people, what were you serving at your Thanksgiving dinner? And let's take a inventory of that. And really what they're asking for at that point is basically from your data standpoint, you kind of think of as an analyst, these are kind of things you would see every day. It's find the total number of the food dishes, find the average number of dishes for a US region, pie, my Oz favorite at Thanksgiving time, how many pies were served across the US region, which I assume the Midwest is going to be a little bit inflated due to me and my family, because that's definitely where we like to focus on. And then of course, bonus, so another piece of it, what is the popular combination of side dishes and how many households are serving it? So really, for people that are new to Alteryx, you can kind of see just from here, it kind of keeps that ribbon interface, kind of like how Excel and Microsoft, but there is just a plethora of different ways you can interact with data in here. Like I said, if Bubba was here and this was shrimp, he wouldn't be able to go on long enough for us to be able to explain all of these. So there's just so many different things that you can do once you get in here. And the great thing about it is they're so dedicated to letting you discover and learn on your own ways. A lot of these will have basically an option where they have examples, where if I were to click this particular tool, it would bring me to an option to show examples of how I want to interact with it. If I'm not comfortable with it, it might help me get down that path. So I'm not going to go super in depth because we'll be here all day if I talk about this. Let's kind of jump into how this prefaces problem is thing. And as we pull some of these tools in to solve this, I'll kind of talk through them the best I can. I don't want to go the whole entire time here. I want to give my colleagues some time. So if we take a look here at what they provided us, really our data looks like what we would expect. Let me go ahead and move that down so I don't have Chris's face in the right corner. So basically you have your main dish, your kind of your sides here. And then if I keep looking, I see my favorite part. I keep scrolling here, pies and dessert. And really, for my data people, this is a very horizontal data set that's really going to lend itself to a lot of column interaction and a lot of things that it just makes your life painful when you're trying to find things like this. So the first thing we're going to come right out of the gate here is a really cool tool that's actually, sorry, let me take that back. We're going to do one step before we get there is we know that each one of these records is basically a family's Thanksgiving dinner, but we don't really have a good way to be able to tell if I were to move this data around, where does that record lie? And if I need to come back to it, how do I reference it? So we're just going to basically use this cool little tool here called the record ID, and we're going to attach it to our input. And then it's going to basically create us a static integer field that's going to continue to count out, kind of like you would expect in a database identifier field, and it's going to stick that at the front. So now if I were to run this again and take a look, we now have a number next to a family's order, or sorry, their family dinner. So now that we have that, what I want to do is take this data, and I'm going this way now. I want to cut it and I want to go down now. So I have a much easier time filtering things out, basically doing counts on different things and grouping values and names together. So they have a nice tool in here called the transpose tool, which basically lets you take a more traditional pivoted style wave data and flipping it. So basically going from a horizontal to a vertical look at your representation of your columns. So I'm not going to go through in depth of how I set this up. Like I said, if anybody ever wants to talk Alteryx, I'm sure we can give emails at the end, but we're going to kind of show this tool's power real quick. So I'm going to go ahead and set this up, and hopefully I do it right the first time so I don't look silly. And then we're going to throw a browser at the end of this and take a look. So now, if you look at it, I went from kind of a little bit of a mess of long to a little bit of vertical. So now I have my family, I have, what they did, and of course the value and what region they're coming from. So to keep going on task number one, and honestly, we might only get through task one. We might have to come back at a later point for that because of all the excitement I'm showing here. So let's go ahead and just finish through with task number one, and that is find the total number of food dishes served in each household. So they consider a food dish any one of these. So turkey, cranberry, gravy, etc. But you can see here in our data, we have some anomalies. So we have like Brussels sprouts, which I personally love. They did not serve those there, but we don't want that to come through in our data. And of course, I think there's also options like with the gravy, that could be no. So another cool thing about this tool is if I were to click in here, it's going to auto curate what values are showing up to me. And it's an easy way for me to go and look and say, okay, great. I now know that there's none, and I now know that there is null in there. We also know there's no, so we don't want those because they didn't basically serve. So what we're going to do here is we're going to quickly put a filter on here, and I'm just going to let it kind of do this for me, and then I'm going to come back to it. So I'm going to first say, is it not null? And then I'm going to go not null, sorry. And then we're going to do, if I can find the and on here, and value, oops, sorry about that. I'm going to, of course, everything underneath the sun. We want it to be also, my keyboard's playing tricks on me, not equal to no. And I can't find the end again. And there we go. Such a small key. It's hard for me to see. And not equal to none. Okay, we do that. Great. And then we're going to run this again. And then we can see now in our true, meaning that everything where that value applied or that statement applied, it gets sent here. Anything that didn't would be in the false. So null, none, etc. So now I have this. Now I know how many different things were served. So now we're just going to simply put a nice little summarize on there. And in here, you can start setting it up. So I want to do it by family, which was our record ID. Or did it want it by, nope, it just wants it by household. And then we're going to go ahead and take the value and we're just going to count it. And then once I'm ready here, I'm just going to run it again. And then you basically get a simple side dish, or sorry, full amount of dishes served at a family Thanksgiving. So I was hoping to get through more of these, but I think that if anybody ever wants to go through these, like I said, if you ever have your own desire to start using Alteryx, please go check out the community website and go have a look at, you know, what's available out there, as it's a really good learning tool. So now, Chris, I'll pop it back to you. Go ahead, Chris.
Just real quick before we leave Alteryx completely.
Yep.
Oh, there's all of us. Hello. Yep, that's the view. We'll just look at you for a minute. So we have some questions that have come in.
Yeah.
So how well does Alteryx interface with data lakes? So ADLS, S3, etc.
Yeah, so obviously the things that are a little bit more non-traditional, they take a little bit more of setup. So obviously if you think of it from a user experience standpoint, it's really going to be easy with simple. Then obviously if you get more advanced, like maybe like an S3 bucket, or of course if you're ingesting data lakes from any, I guess we'll just say database source for that standpoint, it requires configuration, but it does work. It really just depends on what you're trying to accomplish. Obviously, Alteryx has its good use cases, and then of course Alteryx has its not so good use cases where maybe another, excuse me, ETL tool might be more powerful in that situation. So I'm assuming that got to our end of our question. Like I said, I hate to say it depends, but it kind of depends on what you're exactly trying to do. But is it capable of doing that? Yes, with configuration, it could hook up to that.
All right. So next question. I think this one is a little more complex here. So Alteryx allows for easy transformation of data as noted, but this might cause issues when not controlled as designated business. So designated business rules can be circumvented because of how powerful this tool is. Mm-hmm. How do you propose to control this issue if allowing multiple groups within a business to pull data on their own?
Yeah, I mean, this is we could go with the bowl of popcorn all day on this. So this definitely feeds into governance, and it's really putting the power into people's hands. And like you just said, what would stop me from taking a production data marts data that has all the business logic baked in and completely rewriting that in the tool? The answer is, at the end of the day, once they're able to connect to the data and have access to it, it's really basically helping the person that's taking this tool understand what are limitations and what are the use cases for it. So it's building that partnership with your business users, and of course having a good governance policy. And like I said, at the end of the day, if it becomes so extreme that it becomes a problem, always turning off access to it. So yeah, a lot of that questions do get asked with this tool of, you know, how do you stop this so much of a powerful tool from getting into the per se wrong hands and going around all the work that IT has done. What I found has worked best in places that has this tool is it's just a good partnership. It's building a good relationship. It's setting good standards, and it's setting a good governance policy that you're delivering them what they need, and they're not going outside the box to deliver what you can't get to them.
You know, maybe an answer to this, and Bill, you might have some thoughts on this too, or John, but you know, Alteryx is probably not a replacement for an end user access tool like Power BI or Tableau. You know, it really seems much more as a, you know, a Swiss Army knife here for the builders, you know, more behind the scenes.
Right. And when folks get started sharing data, that's really where your governance policy comes into effect. If, you know, if I want to change all my numbers to the wrong numbers on my personal desktop, that's one thing. But if I want to start sharing that data, well, then the company needs a policy of testing data, validating it, approving data sets as shareable, saying who has the power to write to a enterprise data warehouse or sandbox or publish a Tableau report, that kind of thing. So same with Excel, you don't have control over what people do immediately for themselves, but you do on how things are shared.
I'll add one last question and we'll have to move on. Yep. But we were just asked to, so kind of in this note, is metadata, you know, something that can be added in here to help with that regarding Alteryx?
I probably need a little bit more elaboration on where metadata, like, are you talking metadata of like the columns you're bringing in, or, you know, that one, when I hear that one, that I think I need a little bit more clarification on what metadata would mean.
I think if I'm reading that, you know, I guess, can there be a filter between Alteryx and the data that's taking into account, you know, metadata for access or context?
Yeah, so depending on how you're sourcing it, so that's kind of the nature of the problem. So if you're giving me the data in extracts, really at that point it's fair game at that point. But if you're coming from a database standpoint and you're passing credentials, then yes, those policies could come into effect because my account then's tied to whatever I'm able to see. So it just depends on the technology you're feeding into it and how you want to play that out.
All right, so we're going to move on here. So let's talk about Denodo. And Josh, we may, I'll leave it at your discretion here, but we may, just for the sake of time, want to stick to the reference architecture.
Yeah,
if you
absolutely.
think you have something quick we can show in a timely manner, though, that's okay.
No, that's okay. Yeah, and like I said, if anybody wants to see, a live demo endpoint of Denodo, and we'll get all excited about that, please feel free to reach out. But I think, Chris, for the sake of time, we can just go on to the reference architecture and we can give a brief introduction into Denodo and why it has me so excited.
All right, so I got the intro slide up here, so.
Yep, so Denodo, another tool that's kind of pushing this new term of data virtualization out there. So obviously we go back to that 5-7 year ago scenario where I remember my first job, which would be almost 10 years ago. I always found it really funny that the DBAs used to be inside of a closet with the servers, and really you had to have your data, excuse me, on premise with you. And I always thought that was the weird and the coolest thing in the world, that the guy got to sit in kind of a ice box with the servers with our data. Where now what Denodo is really pressing, and what's really awesome about this, is that they're taking the whole thought of moving data from place to place, or having all these disparate data sources and having to bring them into one separate place. They're trying to take that out and letting you basically virtualize that, or let their tool handle the joining and aggregation of this data from all different sources. And then basically they're going to help you push that out to your tool of your choice, or of course expose it as a API. And it's all done nice and neat within their tool. So Chris, if you go to the picture next, excuse me. So if you look at this, one of the hardest challenging problems today people face in data is that you have data coming from everywhere. So Excel, dare I say Access, XML, SAP, CRM, SQL. I could go and keep going with the fingers. And really what the business wanted is, well, I want it all in one nice, neat place, and I don't want to spend a ton of money building this, big, huge data warehouse where I have to move data around all the time. Well, QN data virtualization, where they help you basically take all of these data sources. They provide wrappers for you to be able to connect to them, pull what you want to pull, and then start going on and connect, combine, and consume it. And then, of course, that's going up to your data consumer. So like I said, you can either do it through tools like Tableau and Power BI, or you can do a more application approach and expose it as an API. But really, I think Denodo is going to be something that has got me excited. It's really going to play a big factor in the future as companies start to, take a thought. Is it make more sense to where I have all these systems to virtualize, or does it make more sense to build a more traditional where I want to move the data back and forth?
Thanks, Josh. I'm just going to add one of the things personally that got me excited about Denodo when I first learned about it too is building a data warehouse is such a huge investment. And sometimes Denodo, first of all, can just replace that entirely. But even in cases where you have to have a data warehouse, Denodo is such a great way to do a proof of concept quickly for a lot less money, and just show that if you're in a company where you need a lot of buy-in for a major data project, Denodo is just such a great way to test out new ideas and pretend you have that data warehouse already and see what kind of results you can get from it. That was one of the things I thought was really cool about it too, is it's almost more of a, enables kind of a data laboratory with it as well.
Absolutely.
All right, so we're going to move on here to John McCullough. John, if you want to take the reins, or if you just want to tell me to move slides, you let me know.
I can just go ahead and share real quick. Okay, can everyone see my screen?
Yep, I see myself
right.
on it, so I know I'm seeing your screen.
Excellent. Okay. Well, let's see if I can get you off of there. There we go. All right. Well, Going to touch on a couple of my favorite things about data this year. But before I touch on that, I'm going to touch really quickly on one of my favorite books this year. And it's a book called Children of Ruin by Adrian Tchaikovsky. And it is easily one of my top 3 books where the hero is a rogue software developer that plays by their own rules. And in this book, our brave heroine writes an incredibly clever piece of software that translates regular language into a bunch of flashing lights so that it can be communicated to a group of genetically enhanced space squid so that they can operate an underwater spaceship to communicate with an advanced artificial intelligence that thinks it's a person running on a biological computer made mostly of ants in order to talk to a microscopic alien organism to deliver the critical message of, if you kill all other life in the universe, you will be alone and very, very bored. It's a fantastic book, and without a doubt, it's what makes me think that Adrian Tchaikovsky in a previous life had to be some form of data engineer, because this kind of integration is absolutely systemic to what we're looking at from software integration right now with the way applications are designed. And how do we get to a point where we need so many different levels of integration? Well, talking about the way software was originally designed to communicate, it was all built off of a 3-tier application architecture, or a 3-tier monolith. And that system was designed to be supportable, to have your processes be easily upgradable. But the challenge was that it was only developed with that individual architecture in mind. It was designed to be very upgradable and very, transparent to that one application. But applications were designed to be completely closed systems. It was designed to keep others out, because the real value of your application was making sure that no one else knew how to do what you were doing. Well, that's a very old approach to applications now. Now we know that the real value of an application is how well can it enhance what you're doing. So the old lockdown version of 3-tiered application architecture didn't work for cross-platform integration. Want to integrate with the data tier? You can't. It's encrypted. Want to integrate with the logic tier? You can't. That's obfuscated. Want to get data and information out of the UI presentation layer? Well, you can, but are you really going to write a screen scraper to do that? Definitely not business best practices. So the industry moved to single source of truth kind of architecture. And Josh touched on this just a second ago, the idea that if you could get everything into just one giant on-prem data source, then you've solved all of your problems. From a reporting standpoint, you can put anything on top of this. But the challenge is that this only works when everything already works, when you already have your data in place. But data virtualization is already telling us that there are going to be a whole bunch of different systems that you're going to need to connect on that back end. What happens if you have your source of truth, but that your organization grows primarily through acquisitions? What happens if your source of truth is now combined with someone else's source of truth that's operating on a completely different platform? What happens if you want to look at a modern third-party platform to do a specific software service for you, but they're operating on a closed system or something proprietary? What happens if you're operating on a cluster of ants? Regardless, you have a need to integrate these systems, and just picking them all up and dropping them into one single data set isn't going to absolutely solve your application challenge, because disconnecting the application's data and putting it somewhere else is going to break that application in most instances, especially legacy applications that weren't designed to play nice with others. So my favorite thing about data this year is data virtualization, and the reason that that concept has impacted application architecture. Let's take data virtualization and take the next step. What if we want to take not just our data and provide a unified data layer for us to be able to do reporting off of, but what happens if we want to do a truly integrated application layer? We put in an API mediation layer that can distribute things across multiple application structures, regardless of age, structure, or communication protocols. And this is called a mesh or massa service architecture, or the multi-grain polyglotted backend service. No one calls it that except for Gartner. But if you look at this and say, what are we ultimately trying to do? Well, it's recognizing that your data doesn't reside in the same place across the board. Data virtualization gets you some of that, but it doesn't get you application integration. That is going to be something that changes. Needs aren't set in stone. Legacy applications are usually required for business services because they're critical to a business's particular execution. Integrating legacy applications with modern applications isn't a question of just wiring up a simple service. Very often, these applications don't communicate. So the idea is bring some custom level of application development out of the business layer and down into the data layer to be part of an integrated service, using things like custom adapters in order to communicate with legacy applications, in this diagram. It's a legacy Java application, but it could just as easily be any other kind of legacy platform, and integrating those with modern software as a service architectures using C# mini services or custom API distributed systems. This is taking more of an account that no single system's ever going to cover everything that your business needs to do. To kind of give you a real example of this, I'm going to talk about the worst data set that I have encountered this year. And to say Josh's, Access database, I'm going to predate that by many, many years. This is a legacy terminal application that is running off of a blue screen basic terminal UI. It is a single instance of this application, and to describe it as a monolith is not doing monolith justice. This process predates even individual application architectures, and the process that we were told was that there is no method for extracting information from this legacy architecture. It's 25 years old. Nothing communicates with this. So we went in and did a kind of detailed analysis of what custom process would be required just to do a data extract. And to simplify it, I can tell you that we had to literally write some go-to 10-line basic code in order to take advantage of a export function from this tool, an SSIS translator in order to get this into a flat file data structure, a scheduler for handling all of the different components of this process, a custom design multi-value array handler that we had to put in because this system couldn't have used transactional data. No, it had to use multi-dimensional arrays, which doesn't communicate with anything else. We had to write a custom .NET parser to handle those multi-value values. And once we had that, we eventually had consumable SQL. Job done. We have gotten the data. With this stage, we could even take this and offer it up through a Denodo virtualization process in order to list it as linked data across the board. It's actually the very first thing we did was create some initial linked virtual data sets with this. But we went back and said there is another part of this process that we can look at. Let's take the next step and take this extract process, do the one additional feature that turns this into a full data adapter. What we did at this point was work on a back-end data process, take that extract process and do a write back process mimicking the same architecture. What we now have is a custom adapter. Only in this instance, we're not talking to a legacy Java application. We're talking to literally an AS400 terminal system with old blue screen, no mouse interactions. And we have that linked out through a C# mini service, which offers it up through a modern API layer. At this point, we literally just linked Power BI straight onto that mediation layer and offered the first integrated data sets out to that organization's history. And they had been operating off of this platform for 20 years, 20 plus years, actually. Next step was easy. Data warehousing was already being done on premise and already had standardized integration communication protocols. A couple of days, and we wired that into the exact same process. Salesforce supports integrated mesh architecture. This was a matter of hours to get this established. Now we've got an API mediation layer that's able to access our legacy platforms, our current data warehouses, and our external third-party proprietary systems that have business critical information. But in addition to just being able to do reporting off of this, we now have full CRUD operators through the API mediation layer. This lets us do something really, really cool in terms of application modernizations. Right now, you can't just turn off legacy applications. It's very easy to come in as a consultant and say, your system's old, let's get a new one. But the problem is that no one is currently operating their business off of legacy application that doesn't need that legacy application for their business processes. You can't just turn it off. But if you want to modernize it and it doesn't support scalable user interfaces or any kind of an enterprise architecture, you need a way to be able to get to that back-end business process without turning off that service. That's what this mesh architecture gives you, the ability to have a second process in to get to this data and interact with this platform. You can now go in through the original blue screen terminal applications, or you can go through the modern UI platform, which is currently being designed for this system that calls the exact same functions through the mediation layer, using a lightweight Angular JavaScript front end to be able to offer up all of the services that was originally supported through this legacy program through a new lightweight and scalable enterprise application layer. Using C# mini services to replicate the business process and bringing some of that business logic out of that application business logic tier and down into this distributed mesh architecture. This gives you more control over your application architecture and a way to do true integration regardless of what that back-end process looks like. It's taking that data virtualization and taking it to the next step to full application integration processes. This is taking all of the lessons that we've learned from shared data services and bringing it into modern application architecture and letting you take modern applications and integrate them with legacy applications. It's some of the best of both worlds, and it's really exciting how quickly these kind of processes can be distributed with lightweight custom integrations and just minor adapters. My favorite thing about this mesh architecture is that it's recognizing that systems integration isn't a technical challenge anymore, but a data-driven imperative. We don't have an option whether or not to integrate this kind of information because no one's going to be able to make the correct business decisions if they can't get a comprehensive view of their current environment. And no technical system operates in a vacuum anymore. The challenge is integrating not only your modern systems that are built for communication from the ground up, but also providing a landscape that allows for integration of all of your systems, including legacy and third-party proprietary lockdown systems. Custom connectors can support a lightweight mesh architecture that provides virtualized data layers and virtualized application integrations across cross-platform data projects. This, with standardized communication protocols, enables nimble application architecture at business enterprise scale. And the best thing about this is that it's finally recognizing reality. So many application architectures were designed where as long as everything is perfect, everything will work. This is recognizing that the world is not perfect. Business processes aren't perfect, and not every legacy platform can instantly be replaced. And often there's a really strong business case to not update a legacy program, but to look at more integrations. There's no reason that application portfolios can't support cross-system data integration, even in situations where applications weren't designed with data sharing in mind. Using small, targeted, lightweight adapters, microservices, and C# integrations through a standardized API middle tier, you can get that unified presentation layer across your entire portfolio. And learning what we have about data virtualization and bringing it into application architecture is my personal favorite thing about data this year. So with that, I'm going to hand it back over to Chris. Chris, I think you're on mute. At least I can't hear you, or I haven't surrendered control properly.
John, thank you very much. Stay with me for a minute. So first of all, I'm just going to add real quick, as the marketing guy, I have an obligation to do this. So to summarize, the mesh architecture enables us to work with data from anything from old blue screen, green screen computers to hostile tardigrade aliens in orbit. So you have no excuse for thinking I have a system out here that's too old to work with and there's no way I'm ever going to integrate it. John, I'm going to, we had a question here. The question is, well, first it's a comment. This is beautiful. So the beauty of the data is coming through to the audience. That's wonderful. Can this API mediation layer be compared to tools like Attunity?
I'm not familiar with Attunity in terms of like a custom one. I can tell you what this data layer, there are several applications which are using the concept of an API data layer right now. Things like Apogee, things like Boomi, things like MuleSoft. MuleSoft is certainly one of the industry standards for this right now, that has a whole suite of application connectors already kind of built in. So yeah, there are several different API middleware tools that are currently available to do some of this, and almost all of them have that customization ability to like define custom connectors for any kind of other processes. Obviously, they all have a built-in suite of connectors to your standard ones, your Salesforces, your SAPs, your really large-scale enterprise applications. But then most of them have a flexible language on the back end to be able to do custom connectors as well and bring them into the same mesh architecture. So yes, there are definitely third-party tools that kind of support this kind of application architecture now.
Okay. I don't see any other questions coming. Oh, hold on a second. Just want to check here. Oh, nothing. Just a thank you. So it sounds like it compares to ESB. Does that sound right to you, John?
Yes, this is the modern ESB. Absolutely.
Yeah, okay.
And I didn't want to throw that out initially because people get tired when I talk about legacy ESBs. But yes, this is ESBs and data virtualizations combined. So thank you for whoever asked that question. Yes, absolutely.
All right. Well, they're anonymous, so I can't tell you. But all right. So on to Bill. So Bill, do you want to take control of the presentation?
I will.
All right.
I shall. All right. So let's get rid of you here, Chris. And I'll bring that back up. So what I'm going to be talking about is not as much a specific technology. My favorite thing about data this year is a concept called decision intelligence. And it's been used really in the last year or two to integrate a lot of different disciplines, from data warehousing, AI, machine learning, but also decision analysis, which is going to be the focus of my talk today. So everybody knows, or should know, that we need to be making data-based decisions. We don't need to just be shooting from the hip, working from our gut, doing what so-and-so says, or pursuing a personal crusade. We need to be making decisions that are rational, that help all of our stakeholders, that truly advance the causes of the purpose, the causes of the organization. And so that idea of data-based decisions rings true, and we want to get there, but the focus there is on the data, and the problem can be that we then say, well, let's build this giant data thing and start making decisions off of it. And really what we should be doing is a form of business analysis called decision analysis that really helps us start with the end in mind, and we work backwards from there to the data that we need in order to answer those questions. And then we can start building the structure in a way that is repeatable and automatable, well designed, makes it easy to go back and ask more questions that were anticipated from the beginning. But instead of just building this giant monolith, we have a place to start and a way to justify and estimate the value of our data. So decision analysis, it's a formal discipline, started back in the 70s. And I don't know if you're familiar with this concept of AI winners, but ever since the 50s, there have been surges of interest in AI, and then dead zones where there wasn't any funding. AI was laughed at. We are now in a boom of interest in AI with the advent of really effective neural networks and deep learning. But before really the 2010s, we had this long period of low interest in AI. But before that, in the last big boom, we had a lot of interest in decision support systems, expert systems, recommendation systems that were based on logic. And really, they kind of fizzled out because logic is really expensive. And so you can only code so many if-then statements, and it just doesn't scale well. But now with the advent of machine learning, decision analysis has kind of come back as the tip of the spear when you're doing decision intelligence. And two of the real experts and champions, thought leaders in this are Katsi Kartsarkov out of Google and Lorian Pratt. Both of them are championing this idea of decision intelligence and really not starting with the data, starting with the decision. So you think about a data warehouse, and the end goal is to ship good data, to make it consumable, make it easily accessible by people who aren't technical so that they can make good decisions. And then everything else is in the background and is used to support that, and maybe only technical people understand what's under the hood. But part of the problem is that getting to that decision layer involves so much work, and not just automated coding, but real domain expertise, understanding the semantics of the data, how it's structured, how data from different domains fits together. It's a lot of work. And a lot of times we think that, well, we're not ready for ML. We're not ready for AI. We're not ready for predictive analytics or prescriptive analytics because we don't have this whole foundation. Well, you might be able to get there faster than you think if you start with a few decisions and work your way backwards. So I like the analogy of a cake. You build a cake, or you bake a cake a layer at a time. You stack it up, you add the icing, and then you slice it up, and it's consumed by the slice, built by the layer, consumed by the slice. It's the opposite for a good data system. You don't want to build an entire data lake and then an entire integration layer and then an entire BI layer. And then finally, someday, 10 years from now, get to predictive analytics, ML, AI, all that fun stuff. What you want to do is bake the cake one slice at a time, and each slice is a use case, and not just a use case in terms of a manager keeping his decision criteria to themselves and saying, oh, I want to be able to filter by this field, go do it. The user story shouldn't be, I want to filter by this field. It should be, I need to know X so that I can decide Y, so that I get outcome that maximizes A, B, or C. And so that is the slice. And when you pick a decision layer or a decision slice, you can then build it up from the data management, and you know what you need. You might not need every piece of whatever goes into a modern analytics platform. What you need is just what you need to answer that question. Sometimes the biggest value is in the whiteboarding session. And so we're going to talk about some decision modeling. On the left, decision trees have been around for decades. The idea is you have a decision, there is some uncertainty. So we don't know some event that's going to happen that will affect the outcome of our actions. So we can do A or B, but depending on event X or Y, the outcome will be either favorable or unfavorable. And it's, for a long time, we've been able to draw these trees and say, well, our expected value given the uncertainty is such and such. So even if it might turn out badly, we're going to make decision A because it has the best probability of success. Now, a diagram that's very helpful and intuitive. Decision trees take some specialization or some learning, and they're not as fun. A causal decision diagram, you start with the outcome that you want. You want this one instead of this one, or you've got a variable you want to maximize or minimize. We don't want the seas to rise. We don't want global temperatures to rise more than 2 degrees Celsius. We don't want political polarization to lead to civil war. In this case, we don't want conflict over land rights between cattle herdsmen and farmers to turn into violence. So we want money, we want safety. We want people to be able to grow their crops and to graze. So you have all of these different factors, and you're really starting to talk about not just correlation, which doesn't necessarily imply causation, but you're starting with this idea of, these are things that cause other things to happen, and these are probabilities, and you can start with a common non-technical understanding of a decision problem and work backwards to, well, I need this data in order to know what are the probabilities of X or Y happening, or what is going to be the outcome, or what has been the outcome in the past of various events happening together. So really my favorite part is the whiteboarding. And then I love building matrices. A matrix is a simple two-dimensional diagram. What happens with decision models is that they can quickly become three-dimensional, four-dimensional tesseract. I don't know if you guys have ever heard of the tesseract from Avengers. It doesn't really describe it there, but a tesseract is a four-dimensional cube. Impossible to visualize with our three-dimensional brains. And as you expand the number of options in a decision, the number of scenarios that affect it, the number of criteria that are important to making that decision, the number of stakeholders involved who have an estimate of what's going to happen or not, that all just explodes, how hyperdimensional this cube gets. And really, decision modeling, decision analysis is a way of slicing that down, looking at it in 2 dimensions at a time from different angles, and helping you see, where do I need data to feed this model. And then we can let a computer do a hyperdimensional calculation. So in this example, I'm going to bring up the actual spreadsheet I used here just as a demo. But here we have a simple two-dimensional decision to do or do not. And we've got two scenarios, one where my assumptions are false and one where my assumptions are true. Now here I'm just assuming that I'm going to lose my cost if I do it and my assumptions are false. And I've got some opportunity cost. So if I don't do it and it's false, this is great. I put my money into a 5% mutual fund, and good luck finding 5% mutual funds. But here's my opportunity cost. I lost 5% if it was true and I didn't do it, and maybe I'm going to get a 10% ROI. Now, if my chances are only 60%, a 10% ROI does not justify doing it. But let's say I've got a 25% chance of doing it, or ROI, and I can be 80% true or sure that it's going to happen. Well, then I should do it. Or let's say, well, I'm going to start a new business, and 1 in 5 businesses make it 5 years. So I've only got a 20% chance, but I might triple my investment. So what that gives you is this nice, cool curve where all of it's a two-dimensional curve. Everything I do to these numbers in gray will change the shape of that curve. But when I go to look at the curve, I've only got 2 dimensions. One is return and one is how sure I am. So the higher your return, if I'm going to, multiply my investment by 10 times, well, I only got to be 6% sure it's going to work out. So that is kind of the basics of what I call taming the tesseract, taking that multi-dimensional, hyperdimensional decision problem, boiling it down, and then we're going to see, can I get data to support, is it 40-60? Is it 20-80? And then what's my criteria? If you've heard of a video game where folks program a computer to play a video game with AI, and all it does is go around looking for coins. It doesn't try to win the game or get to the next level. That's a situation where the utility function has not been optimized correctly. Or there's a thought experiment about a AI paperclip factory that is only optimized to make as many paper clips as it can, and ends up taking over the world and turning the entire globe into paper clips. That is a non-optimized utility function that can take many different criteria for success and basically break them down into one number that it should maximize or minimize. And here I want you to see that you can get from a highly dimensional matrix, array, tesseract, hypercube of scenarios, options, and criteria, and you can unpivot them. Josh talked about unpivoting or going from a wide to a long data set. And that's exactly what we do when we create an ML data set. You take all of your scenarios and you break them down into multiple columns. You take all your options, you break them down into multiple columns. You end up getting a lot of rows, but what it does is you end up with an outcome to forecast and optimize. And that is really how AI works. It's how machine learning gets you to recommending options. And in some cases where the risk of failure is low and the frequency of decisions are high, we're already using AI to take action on those decisions. So I want to end with this concept of the value of information. It's a formal theory. You can look up value of information a lot of places. And the idea is that, information is only valuable if it makes a difference. If you're going to do the same thing no matter what, don't gather any information. Don't gather too much information, because it costs a lot. Information's expensive. Data systems are expensive in time and effort, number of people involved. So the value of information is really related to the difference between the value of a decision made without it and the expected value of a decision made with that information. So you can use various calculations to say, is it worth, say, drilling a test hole in this oil field to see, does it really have oil? Or should we just, go for it and drill, or should we just pass it over? The value of the decision of the test is based on the value of the decision without testing or with testing. So you never want to be this guy out here spending too much on building a system where you could have curved your effort right here and gotten the most AI. And the way you do this, again, is by going slice by slice. You want to build your data system decision by decision. And whatever data you need for that decision, you bring along adjacent data, you model it in a nice, easily consumable way that's repeatable, but you don't have to build the entire thing out if you start with decision analysis, a formal process of structuring your decisions and deciding what data you need. It's really going to give you the biggest bang for your buck.
Thanks, Bill. So in conclusion, if you start by understanding the decisions that you need to make before you start diving into your data strategy, you just might be able to have your cake and eat it too. We kind of went the gamut here of, big technical to ideas to concepts to ants. I hope everyone got something out of it. And thanks, Josh, John, and Bill, all for being here today.